Hi, it's MP the tutor here, and today we're going to be looking at the quadratic graph. And on screen I've written a little quadratic function, and this also could be written as y equals x squared plus 2x minus 8. And both of those there are the same thing. Now, when they want you to draw a quadratic graph, or sketch it at least, they just want you to draw it freehand. It doesn't have to be 100% accurate. So a quadratic graph will make a U shape. So in this case, it will look something like this. Now, there's a few things that they want to make sure when you're sketching it, to make sure it doesn't do. So for example, if I made it go on itself, I know that's stupidly extreme. If you go back on yourself at all, that would be wrong. You lose a mark. If it then starts getting less steep as you're drawing it, again, that's wrong again. And what they want is we need to mark on the points where it crosses the axes. This is our x-axis and our y-axis, and the minimum point. Now, the graph, the U shape, can be anywhere like that. So it could have been moved up. It might be on this side. It might be over here. Or it can even invert itself. So it can be upside down. So it could be like that. And that's, again, the same graph. Sometimes you'll find that it's below the axes, it doesn't cross the x-axis, but it will always cross the y-axis at some point. Let me rotate that back to make sure it's actually this graph we're aiming towards, and it'll be something like that. Now, let's have a little look at this example. Well, to find where it crosses the axes, we need to go for when it equals 0. That's both for y equals 0 and x equals 0. So when x equals 0, or we can go y equals 0 minus 2, 0 plus 4. Well, that's minus 2 times 4, which is minus 8. So this point down here is at y equals minus 8. So that point's at minus 8. I mean, you can just leave it as minus 8, but you could have it as coordinate. So we could go for 0 minus 8. When y equals 0, we have 0 equals x minus 2, x plus 4. Then we have x minus 2 equals 0, which means that x equals 2, and x plus 4 equals 0, and therefore x equals minus 4. So this point is x minus 4, but you could have its coordinate of minus 4, 0. This point over here is at 2, 0. Now, what about the minimum point? Well, there's several ways you can go about that. We could do completing the square. So I'm going to go down the route of computing the square. Square to find the minimum. So we have y equals x squared plus 2x minus 8. Well, then we have y equals, we have x plus 1 in bracket squared. We have that minus 1 minus 8, which means that y equals x plus 1 in brackets squared minus 9. our minimum is when x plus 1 equals 0, or x equals minus 1. So our y is minus 1 plus 1 squared, which is 0, minus 9, or y equals minus 9. So our minimum equals minus 1 minus 9, which would be that point there. Minus 1 minus 9. But is there another way? Well, we could use another way. So another way could be differentiation, which is chapter 12. But that is what that will go on to when we get to chapter 12, and gradients of curves, and when you find a minimum through quadratics and cubics and other graphs. So the completing the square method only works for quadratics and finding minimum then. So the minimum is at the midpoint of the roots of a quadratic. Well, what do I mean by that? Well, if I go back up to the graph, and we have x is minus 4 and x is 2. So that's basically when you got your 0 equals x plus 4, x minus 2. We had x equals minus 4 and x equals 2. The minimum point is the mid point of x equals minus 4 and x equals 2. So the midpoint equals minus 4 plus 2 over 2, which is minus 1. So that means x equals minus 1. And then you can plug that into our equation of y equals x plus 4, x minus 2. So y equals minus 1 plus 4, minus 1 minus 2. What does that get us? Well, that gets us 3 times minus 3, which is minus 9. Minus 1 minus 9. So that is the same value as the computing square, where we basically choose the midpoint of our roots. So the midpoint of minus 4 and 2 is at minus 1. And then we plug that minus 1 value into our function to work out our y value. Both are equally valid, and you just solve it that way. So let's have a little look at this next one. So this is sketch the graph y equals x squared minus 5x minus 14. So before we do any curves, we need to actually work out roughly where it will cross the axes. So what we're going to do is when x equals 0, y equals 0 squared minus 5 lots of 0 minus 14. So y equals minus 14 when x is 0. So that's somewhere down beneath the axis. When y equals 0, 0 equals x squared minus 5x 14. Now in this example, I've made it factorizable. So 0 equals, with brackets, we have an x and an x. One's a positive, one's a negative. And we have the factors of 14, which is 1 times 14, and 2 times 7. Well, let's clear the second one. We have a plus 2 minus 7. And that then is factorized, but we haven't solved it. What we then have is x equals minus 2 4x equals 7. Now, on this occasion, it's factorizable, but you could use a quadratic formula, it's perfectly valid as well. But what we now know is that x is minus 2 and x is 7 is going to cross the axis. So somewhere to, like, you have over there and over there. Now, I don't particularly like drawing the crosses first because you then end up having to try and link them up exactly. However, what we are going to do is we're going to draw a curve. We're going to make sure that our minimum points on the positive side, because this point here is at 7, this point here is at minus 2, and our minimum point is the midpoint of minus 2 and 7. So the mid of minus 2 and 7, that's 7 minus 2 over 2. 7 minus 2 is 5, divided by 2 is 2.5. So I now already know, so how quick it is, that's 2.5. This point here was at minus 14. So we now need to work out what the y value is for the minimum point. So the min was the middle of minimum point is when x equals 2.5, because it's the middle of our minus 2 and 7. But what about y? So y equals x squared minus 5x minus 14. So we just plug in the values. So y equals 2.5 squared minus 5 lots of 2.5 minus 14. 2.5 squared is 6.25 minus the 5.5 times 2.5 is 12.5 minus 14. And you can plug that in a calculator or work it however you like, and then you get minus 20.25. So that is our 20.25 is our minimum point here. So min point is 2.5, 20.25. And just doing the midpoint of two separate bits is often easier than completing the square. But if I go across, now you can see the whole thing. So we sketch the graph, you work out when x is 0, then you work out when y is 0, and to find the minimum point, we basically need to work out the midpoint of our intersections with the x-axis. So here we have another one which looks very similar. So we first will go when x equals 0, y equals 0 squared minus 4 lots of 0 plus 20, which is 20. Nice and simple. So what about when y equals 0? Well, then we have 0 equals x squared minus 4x plus 20. We could plug this in a calculator and with the quadratic formula, and it will go math error. Not with the exclamation mark, but it'll go math error. And that basically means that it doesn't actually cross the x-axis. So this graph, if I draw the axes, will look a bit like this. Now, what about the minimum point? And how do I know which side of that axis it's on? So is it over this side and looks like that, or is it on the other side and looks like that? Well, there's a couple of ways. You can do completing the square. So what about this example, where we don't actually have 2 points where it crosses the axes? Well, what we can do is we can actually say, well, let's put a line across virtually and say this point is at 0 and this point is something else. Now, this is when y equals 20. So you then go 20 equals x squared minus 4x plus 20. And I'm going to take away the 20 from both sides to get to 0 equals x squared minus 4x. What we can then do is you can then factorize out the x brackets x minus 4, and then we divide, well, then we work them out. So x equals 0, x minus 4 equals 0, and that means that x equals 4. So this point will be at 420, and this is 020. So we're just choosing 2 points which are the same height. I tend to go for where it crosses the axes and the same height of them. Now the minimum is the mid point of 0 and 4. So the minimum in this case is when x equals 2. Now we want to then work out y. Well, y equals 2 squared, and that's 4 lots of 2, plus 20. So we have y equals x squared minus 4x. And if we plug that in a calculator or type it out, you get 4 minus 8 plus 20, which is 16. So this minimum point here is at 2, 16. Now what we don't want on this sketch is we don't want that red line there, which I've just deleted. So that's just part of our working out stage and me just showing you. But our minimum point in this case is 216, and it makes a graph over like that. We also could use completing the square. So we have y equals x squared minus 4x plus 20. We then have y equals x minus 2 squared minus 4 minus 20. And then y equals x minus 2 in brackets squared. That should be plus 20. And then that's for it's plus 16. And then we have minimum is when x minus 2 equals 0, and therefore x equals 2, and y equals 0 squared plus 16, so y equals 16. So again, we get the same answer, 2 different methods. And again, you could do differentiation once you've learnt it, which will be coming up in chapter 12. This example, we've got 4x squared plus 7x minus 15. That's a little bit more fiddly. So what we're going to do is when x equals 0, y would equal what you got? 4 times 0 squared, 0, plus 7 lots of 0 is another 0, minus 15. So it's just minus 15. Now, when y equals 0, well then 0 equals 4x squared plus 7x minus 15. We can use the quadratic formula. So you've got minus b plus or minus the square root of b squared minus 4ac all over 2a, where a is the number of x's, x squared, which is 4, b is the number of x's, which is 7, and c is the number of units, which is minus 15. So we type that in a calculator, and you get x equals minus 7 plus or minus the square root of 7 squared minus 4 times minus 15 over 2 times 4. So plug that in a calculator, and what do we get? What we have, you have x equals 5 over 4. And we have x equals, and scroll back in, change it to a minus on my calculator, and you get minus 3. So we already can then have our little axes. It's going to be something like this, where it's going to be a minimum point on the other side. This point here is 5 over 4, and this point here is minus 3. What about for the minimum? So the min is the mid point of 1.25 and minus 3. So we go 1.25 minus 3 over 2. Well, what's that equal? And you get minus 0.875 or minus 7 over 8. So we now know that this point here at the minimum is you typically do minus 7/8 as a fraction. So what about for y? Well, y equals 4 lots of minus 7/8 squared plus 7 lots of minus 7/8 plus minus 15. Put in a calculator, and we get minus 289 over 16, or minus 18.0625. Now I keep it as a fraction, not particularly nice. Minus 289 over 16. And this point here was at minus 15. So you can just label them as arrows or whatever with numbers. At minimum point, you need a coordinate. It's not particularly nice, but the min point is equals minus 7/8 minus 289 over 16. And again, you could have used complete square. You could have used differentiation to find the minimum point. Both are perfectly fine. They don't really care as long as you get the answer and you've sketched it correctly, with the minimum on the negative side of x in this case. So here we have another graph, and we have y equals ax squared plus bx plus c. Find a, b, and c. Now this time, the graph's been sketched or drawn for us, and we know where it crosses the y-axis and where it crosses the x-axis. And what we know is that the roots are when x equals minus 2 or x equals 5. What we can do with the roots is we can actually find out the factorizable brackets of a quadratic. So we then have x equals minus 2 or x equals 5. We're going to make them equal 0. So you have x plus 2 equals 0, and that's one of the brackets, or x minus 5 brackets equals 0. So what we now have are these two brackets for a quadratic, and you go y equals a certain number, which is in fact a, brackets x plus 2, x minus 5. What we can then do is use that when x equals 0, y equals minus 40, because that's the y-intercept. So we can just plug in these numbers. So minus 40 equals a bracket 0 plus 2 and 0 minus 5, or minus 40 equals a, and then 2 times minus 5 is times minus 10, or minus 40 equals minus 10a, and therefore a equals 4. What we then have is y is 4 lots of x plus 2, x minus 5. Now, the format I want it in is ax squared plus bx plus c, so I need to expand out that bracket. Those brackets first, so x and 2, x and minus 5, your x squared, 2x, minus 5x, and minus 10. If you're not sure about the expanding brackets like this, then you can always look back at expanding brackets, which is towards the very beginning of the textbook, which I'll leave its link in the description. So what we then have is y equal 4 lots of x squared, and then 2x minus 5x is minus 3x minus 10, and then I need to expand out that bracket, so I need to times everything by 4. So you have y equals 4x squared minus 12x minus 40. So that is what that graph looks like. So let me zoom out so you can get all in. So that graph is now in the form of 4x squared minus 12x minus 40. Is that graph there sketched out? So let's have a little look at this next one. This is basically the same sort of thing, but we have it upside down, which means that a at some point will be negative, but we're just going to have basically x equals minus 5 and x equals 4. That means that x plus 5 equals 0, or x minus 4 equals 0. So that's our two brackets. So you have y equals a bracket x plus 5, x minus 4. Then we go that when x equals 0, y equals 10. So 10 equals a bracket 0 plus 5, 0 minus 4. Well, that means that a, 10, is minus 20a. And therefore a is minus 10 over 20, or equals minus 0.5. So then we have y is minus 0.5, lots of x plus 5, x minus 4. We then expand out that bracket, x and 5, x minus 4. That gets you x squared, a 5x, a minus 4x, and a minus 20. So we have y is minus 0.5, or minus a half of x squared. 5 minus 4 is 1, so plus x minus 20. We're going to then multiply that by 0.5, or minus 0.5. So you get y is minus 0.5 x squared minus 0.5 x plus 10. So have a go at exercise 2F. Question 1 is about sketching the graph, and question 2 is about what we just did with working out the equation of the graph using a sketch and the points of intersection with the axes. So have a go now, and I'll put the answers on the screen just now. So spend a moment, pause the screen, and mark them. So there's quite a few answers, quite a few sketches. So hopefully you can have a go at most of those. Like I said, it is worthwhile doing just to make sure you're confident with sketching these graphs in case they come up.